All right, 8th graders, lesson 53, measures of central tendency. If we review those here, remember mean is the average, median is the middle number, and mode is the most frequent number. All right, so first of all, to work with measures of central tendency, we need a lot of data. And so here we've got that data that you see in your book there on page 361. And down below they've put it into a line plot down there, so you can see that in your books maybe a little bit more clearly. The first number up here is 16, so down here on the number line they put an X at 16, next is 15.2. So you see that down there, and so on and so on, so forth. So you have to remember that. Well, I lost mean mode, but this is a line plot down there. And we'll be using that here today. So to figure out the mean, we would have to add all of these numbers here, and in this case divide by, well, we've got 4 rows and 5 total, or 4 columns I should say, 5 total rows, so that's 20. So whatever number we got when we added them all up, we would divide by 20 to figure out the average. The median we would take, and that's where this number line comes in handy. We have a total of 20 pieces of data, so if we count to the 10th and 11th data, that will help us know what the median is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 10th piece of data is 15.2. Now the next one is not 15.2, it's 15.3. So I have to add both of those and divide them by 2 to figure out what my median would be. So now on a number line, I know between 15.2 and 15.3, if we add zeros there, hey, that's 20 and 30. The middle number will be 15.25. So that's going to be my median, 15.25. I could also solve that here by adding these two together and then dividing by 2. The mode is the number that happens the most frequently. In this case, I've got 3 different numbers that have 2, but I don't have any that have 3. So in this case, the mode could be those 3 numbers. That wouldn't be a problem to have many modes. The range is going to be the difference between the largest and the smallest. So in this case, 16.1, and over here 14.2. So I would subtract those 2, and the difference between the 2 would be the range. All right, next we go to histograms. This is a histogram. It's different from a bar graph. A bar graph would look like this, and a bar graph has these spaces in between the bars. A histogram does not, and that's because its numbers down here are continuous, 14 to 14.5 to 15 to 15.5. There's no gaps between the numbers. Here, over on this one, there might be gaps between, and usually we might be like a favorite pet, dog, cats, and fish. So we won't put the dogs right next to the cats, right next to fish, because it's not like it's a continuous number line that it is here. So that's what makes this a histogram, is these all touch each other, the bars do, as they go up and down. Now, one thing they don't show here is on a histogram, sometimes we see that, and that might mean we always start at 0, but let's say our next data comes at 100, and we're going up by tens. That symbol there just signifies that we've skipped some numbers. So that's a review of a histogram. So let's take a look at examples that we've got here to work with. So we'll start with example. All right, in example 1 here, we have our data. Over here we've got our number line, so we can start putting date on. We've got a 28 up here, so we'll put an X right there for 28. We got a 33, 31, 41, 42, 27, 75 right in the middle there, 73, 38, and a 35. So that would be our number line here. All right. First, then it says, which measure mean, median, or mode? Well, first we got to find the mean, median, and mode. So we add all of those up. And for the mean, we get 423 as our total number. And we've got a total of 10 pieces of information, so I'm just going to have to move the decimal there. So the mean will be 42.3. Oops. I gotta learn how to spell there. Median is the middle number because I've got 10 pieces of information. 1, 2, 3, 4, 5 comes between the fifth and the sixth piece of information, which are 35 plus 38, and then I'll divide those by 2. So that will be, well, I know 36. That's the difference here is 3. So half of 3 is 1.5. So lots of ways to do it. We could get, let's show here. This would be 73 divided by 2. Alright, and that's going to equal 36.5. So that's going to be our median. Now, I like to look at the difference between these two here, and that's 3. 3 divided by 2 equals 1.5. So 1.5 plus 35 is going to be 36.5. So that's another way of finding the median. Alright, now we need to go to the mode. And in this case, no number occurs more frequently. We wouldn't want to list all of them, so we would just say no mode. Range here, well, that's going to be the largest number that we have, which was 75, and we subtract the smallest number. Let's see, that was 27. So over here we can do 75 minus 27 becomes a 6, 15, 8. So our range here is 48. Now, B asks which of these 3 that we have here, which one best represents the typical age of the customers. Okay. When we use the average in this situation, because the average is it's gonna be a little high. It's gonna be up over here. And we see actually most people are over in this vicinity. So we want a number that's in here. So range, well, that doesn't help us. So median is going to be the best representative, about 36 years old. These two pieces of data, these outliers as we cause them, cause the average to go from here to way up over here. And that's not a true representation. We got 2 oddballs. A better representation would be a number right over here somewhere, which is 36. Alright, now we go on to example 2. Suppose the median age of residents in a state was 30. So we say the median is 30. 20 years later it is 37. It's 20 years later. What changes in the population may have occurred in the 20 years? So again, the median. So what we might say is if we have a number line here, and this is say 20, this will be 30, and this will be 40. This was the median over here, but now it's way up over here. So for this to be in the middle, we must have got more people over here and less people over here. So how does that happen? Well, to get more people over on this side, people are living longer. So we put that there, people living longer. And another thing might be is maybe people are having less children. So we might say less children. So the state's median age would go up, and that's quite a significant number to go up to 37 in only 20 years. That means you're having a lot of elderly people either move in or a lot of young people move out, so that the numbers are skewed this direction a little bit more. So our answer for example 2 would be more of a sentence form. If people are having less children, that would affect it. If people are living longer, that would affect it. If more young couples are moving out of your state, that would affect it. If more older people are moving into your state like Florida, a lot of old people move there because of nice weather, so they're going to have a higher median. So that's example 2. All right, in example 3, we've got to consider the salary in thousands of all of these people. And I really like this example because this again shows how you can make data misleading. If you were to go to this job and they say, well, the average salary is $50,000, you'd say, I like that. That's a pretty good number. Well, if you look at all these numbers over here, you see 30, 30, 30, 30, 30, 40, 40, 60, 80, and 90. Well, where are most people? Most people are in the 30s over here. So that is very deceptive. And the reason is, if we were to draw a number line here, you got your 30s, and here you got 100. Most of the people are ending up over here. You got 2 more here in the, let's say that's 40 and 50, 60, and you got a couple of people way out over here. Well, that makes the average end up over here around 50, when in reality, the real information they should be giving you before they hire you is, in reality, you're probably going to be in the 30,000s. So again, this would be an answer that you would give as a sentence, and they're asking how might it be for misleading. You would say the mean is not an accurate representation because only a couple of people are actually in that area. These people up here, most people are in this area, so it's misleading. A better guide would be if the person who was hiring told you what the median salary is. So if you ever do go to a company and ask what's your average salary, it's probably not a good question. You should ask what's your most common salary, median. But then you can ask, how do I get up to here? How do I get into this area? And they might tell you, well, you need to do these skills and learn these things, and that will better equip you. All right, and finally, 8th graders, example 4 here. Josiah sells 3 different hats to test their popularity. His sales are reported in this graph over here. So the height responds to the number. So we can see here he sold 10 of these, looks like 4 of these, and 7 of these. So what is the mode of the data? Well, the mode is going to be type 1 because that is the most frequent number. And why are we not interested in the mean or the median? Well, as a businessman, I want to know what I'm going to sell the most of. So an average of all of these really isn't going to help me. And neither is the median, the number that's in the middle. I want to know what most people are buying because next time I order, that's what I'm going to order most of. So as a businessman, in this instance, mode is the best piece of information because it tells me what most people are purchasing. So that's the type of information I'd be looking for there. So in this lesson, as you can see, it's not so much always about the numbers as it is about understanding the numbers and being able to interpret them. And that's a very important skill to have as a person in the real world and the working world, is how well can you interpret data, and can you show us that you're not going to be fooled by it.